Have you ever been standing on basalt and then looked up 1,000 feet above your current elevation and realized that the same basalt actually crops out up there? Well, in that case, you may be in eastern Washington, where lots of weird stuff has happened with the basalts in this area. And in that case, you better know a basalt. North of Saddle Mountains and east of Beverly is a public fishing access and at the Beverly Dunes ORV site, which also has an outcrop of the Priest Rapids member, which is the youngest member of the Saddle Mountains, which is the youngest member of the Wanapum Basalts. The Wanapum Basalts were originally thought to be about 14.5 million years old, but in the last couple decades, and I think mostly in the last few years actually, the ages have been revised to somewhere between 15.1 and 15.8 million years. And it's not between those two, it's probably either 15.1 or 15.8, depending on who you talk to. And here at the Beverly site, it looks like the Priest Rapids member or weather's pretty much just gray. There's some lichen on this one, but we've got a definitely not a colonnade, so I guess it's kind of entablature flow with some horizontal jointing. And in this case, that's because the region that this is in has been under a lot of compressional stress. And so there's probably a lot of fractures as these are both pushed up and northward, or southward and northward, depending on how you look at it. In other areas, like further east at the Drumheller channels, the Priest Rapids has some well-developed colonnades, but unfortunately that area is currently closed because it's waterfowl breeding season. And let's grab a fresh sample here. Even you can see that brown on the inside is definitely weathered. It's a very colorfully weathered rock on the inside here. Well, I guess we'll have to make do with a weathered sample because I can't find any fresh stuff. But we've got a lot of alteration of the plagioclase and pyroxenes that are in there. You can kind of tell there's different crystals just because it's weathering, but if it wasn't weathered different colors, you wouldn't be able to tell them apart. So this is a very fine grained to somewhat medium grained apheric. It's dictytaxitic. The framework of the basalt is made up of interlocking plagioclase crystals, which you might remember from the Asotin video. Compared to many of the later Saddle Mountains basalts, the Priest Rapids member is fairly massive, and it's split up into two flows called the Lolo and Rosalia flows. We've got a little bit of outcrop here, but it can be up to 70 meters thick in some valleys, although it is thinner on the ridges. The sand in this area looks very immature in that it's fairly coarse-grained with not the best sorting, and a lot of the grains up close are very angular. And one of the interesting things is that there's actually quite a lot of basalt pieces in there from the local basalts, obviously. As we leave the Beverly public fishing access area and come up here, give you a better view of the surrounding area at the top of this flow, or the top of what's exposed here. And you can see, maybe perhaps it's sloping very gently down towards the left here, which is south. And as I pan to the south, this is the north face of Saddle Mountain. So the Priest Rapids member is down here, but it's also up there where it covers the petrified wood that you find at the top of Saddle Mountain. And as I mentioned, there's compression here, and that's exactly what's going on, where this whole unit of Saddle Mountain was pushed up after the Priest Rapids member was deposited. The Priest Rapids basalt has up to 1.5 meter diameter columns, which would be pretty impressive to see, but Unfortunately, you'll have to wait until we talk about the Rosa member to see some pretty impressive columns. And in the meantime, I hope you enjoyed learning about the Priest Rapids member, and I hope you'll join me next time as we get to better know a basalt.